Hello, everyone. Welcome to this video on learning mathematics through concepts and examples. Today, we are going to solve an example problem on analyzing the function represented by equation using the derivative. So it's going to be a long example. It has 3 parts, so we are going to solve it. So here is the question. Consider the function f of x equal to x cubed over 3 minus x squared minus 8x plus 3. So let's solve the first part. In the first part, we have to find the intervals on which the function is increasing and the interval on which the function is decreasing. So let me write that function first. We have f of x equal to x cubed over 3 minus x squared minus 8x plus 3. So what we know is function is increasing if the derivative of the function is positive, and the function is decreasing if the derivative of the function is negative. In other words, the function is increasing if the derivative is positive. We write like this. If the derivative is positive, f prime x is greater than 0, and decreasing if the derivative of the function is less than 0 or negative. So what we need to do first is we need to find the derivative of this function. So let's find the derivative. F prime x is equal to that 3 in the denominator, where we have x cubed over 3 is a constant. So we can write as it is. And for the numerator, the derivative of x cubed is 3x squared and minus derivative of x squared is 2x. And then the derivative of minus 8x is negative 8. And the derivative of 3 is 0. So we can write it as f prime x is equal to, the derivative is equal to 3 and 3 cancel. It will be x squared minus 2x minus 8. Okay. Now, this is the derivative. We have to find where this function is positive and where it is negative. So what I'm going to do is I'm going to factor this quickly. So we can factor that, okay? And we have x squared minus 2x minus 8. So if you factor that, the factors will be x minus 4 times x plus 2. We can factor it like that. Now, what I'm going to do is, in order to make our work a little easy here, I'm going to sketch the graph of this one. This is a quadratic function which opens upward because the leading coefficient is 1. So sometimes if we use the graph, our work will be much easier. So that's what I'm going to do here. I'm going to sketch the graph of that function. So this is my x-axis, that is y-axis. And we can see that this function, the derivative will be 0 if x minus 4 is equal to 0 or x equal to 4. At x equal to 4, this will be 0. So that is at 4. And also it will be 0 at negative 2. Negative 2. And we already know that this is a quadratic function which opens up. So we can sketch the graph that opens upward like that. So this is the graph of the derivative of that given function. Okay, this is the graph of the derivative of that function. So this is the graph of f prime x. So what you can see is this function is negative between negative 2 and 4. That means the function is decreasing in that interval. And here from negative infinity up to 2, the function is positive. It's above the x-axis. Here also from 4 up to infinity, the graph is above the x-axis, meaning of that is it is positive. So in that interval, it is increasing. So we say that the original function, f of x is increasing. Okay, f of x is increasing on this interval from negative infinity up to negative 2, negative infinity up to negative 2. And also here in this interval from 4 up to infinity, it is also positive. So from 4 up to infinity. And if we want to combine these two, we put u in the middle, union sign. Okay, so the function, the original function, this function is increasing on that interval. Similarly, the function is decreasing. Function is decreasing here from -2 up to 2 because the derivative is negative. You can see that the y values are negative there. So the derivative is negative. Meaning of that is original function is decreasing from -2 up to 4. Decreasing on this interval, -2 up to 4. And remember, these points here, this one, 4, 0, that x is 4, so y will be 0. So I can write that as 4, 0. Okay, that 4, 0, and this one, -2, 0. -2, 0. These 2 points, this one and this one, they are the critical points. These are critical points. So critical, this is one critical point there, this point. Let me also write the other one here. Critical point. So that is the other critical point. Note that this original function has a maximum or minimum value at these critical points. So this is the first part. So in the first part, we are just asked to find where the function is increasing and where it is decreasing. So always remember, for the function to be increasing, the derivative should be positive. And for the function to be decreasing, the derivative must be negative. Okay, now we are going to work on this B, where it says, determine the interval or maybe intervals on which the function is concave up and the interval on which the function is concave down. So let's work on B. I'm going to copy that second part B here. Okay, let me put that B there. Now let's solve this one. So in order to find where the function is concave up or concave down, always remember, when we are talking about the function being concave up or concave down, we are talking about the second derivative. Okay, so the function will be concave up if the second derivative of the function is positive. And it will be concave down if the second derivative of the function, okay, second derivative of the function is negative. So let's find the second derivative of the function. What we already know is from the first part, we know the first derivative. The first derivative of the function is, let me go back and show you. This is our first derivative, x squared minus 2x minus 8. Okay, x squared minus 2x minus 8. That is the first derivative. So the second derivative will be, you find the derivative again. The derivative of x squared is 2x. And then minus, derivative of 2x is 2. And derivative of 8 will be 0. So just like in the previous one, what I'm going to do is, I'm going to sketch the graph of this second derivative, 2x minus 2, a linear function. Let me sketch the graph of linear function here at the side, like this. And you can see that this is a linear function with y-intercept negative. Slope positive means it goes up. So like that. That is the graph of that function. Now, if you want to find this x-intercept, that is when y equal to 0, or when is this function 2x minus 2 equal to 0, it is at x equal to 1. So this point is 1, 0. Okay, so the graph we have drawn here is the graph of the second derivative of the function. And what you see is the second derivative of the function is negative. It is below the x-axis here, means negative, from negative infinity up to 1. And then it is positive from 1 up to infinity. It is above the x-axis. So that means the original function is concave down in this interval. Concave down because the second derivative is negative. And concave up here from 1 up to infinity because the second derivative is positive. So we can write that answer. So we can say f of x, the original function, is concave up. Okay, the graph of the original function is concave up on the interval from 1 up to infinity. From 1 up to infinity, because the second derivative is positive. And the original function is concave down, or the graph of the original function is concave down on this interval from negative infinity up to 1. Negative infinity up to 1. Because the derivative is negative. The second derivative is negative there. So that is the second part of the question. We are asked to determine the interval on which the, function is concave up or concave down. We got that. And this point here, 1, 0, this point is called the inflection point. Remember, the place where the second derivative is 0, that is the inflection point. That is inflection point, the point where the concavity changes, because this side, it is concave down on that interval, and after that, the function will be concave up. That's why that point is the inflection point. Okay, that is the second part. Now, let's look at the third part. So in the third part here, you can see that we are asked to find the points on the curve, and we have to find as an ordered pair, by the way, okay, where we have local maximum or local minimum. So let's go here and work on that C. Let me paste that here. I copied and pasted here. Now let's talk about this. So that's our C. We have to find the point or points on the curve as ordered pair where the function have a local maximum or local minimum value. Okay, now let's see what we know so far. So this is what we have. Let me write. We have the original function f of x. F of x equal to x cubed over 3 minus x squared minus 8x plus 3. We also know the first derivative. First derivative is equal to x squared minus 2x minus 8. And the critical points, let me write here. Critical points at x equal to -2 and 4. We have the critical point at x equal to -2 and 4. That's what we know from the first part, -2 and 4. And then the other thing is we also have the second derivative and the inflection point at 1. So we also have the second derivative is equal to, okay, our second derivative is 2x minus 2 and inflection points at we just have 1, so I can write inflection point, okay? Inflection point at x equal to 1. Okay, that is what we know so far. The question here is, we have to find the points or points on the curve as an ordered pair where we have a local maximum or minimum. Remember, the local maximum or minimum occurs at the critical point. So local maximum or minimum always occurs at the critical point. So the maximum or minimum value will be here at -2 or 4. Okay? But how we know is we put these values into the second derivative to determine that. So what I mean by that, let's see. Let's plug in. Let's find the second derivative, okay? Let's find the second derivative at -2. At -2. So we plug in -2 into the second derivative. So this will be 2 times -2 minus 2. So 2 times -2 is a -4. -4 minus 2 is a -6. -6. So second derivative is negative. So meaning of that is If the second derivative is negative, the function is maximum. Okay, function is maximum at that critical point. So in this case, it is at x equal to -2, because when we plug in -2, the second derivative is negative. So since the second derivative is negative, the function is maximum at that point, maximum at x equal to -2. Okay, so you have the maximum value there. Now let's see what happened at 4. So second derivative at 4 is equal to, we plug in 4 here. So 2 times 4 minus 2, which is equal to 2 times 4 is 8. 8 minus 2 is a positive 6. So positive 6, meaning the second derivative is positive, meaning the original function is minimum. Okay, minimum at x equal to 4. That's what we know. So we know where it is maximum and where it is minimum. And we are asked to find the point of the curve where we have maximum or minimum. We have maximum or minimum at -2 and 4. So we have to find the value of the function to get that ordered pair. So let's find the value of the function. Let's find the value of the function at -2. If I want to find the value of the function at -2, I need to plug in -2 into this function. So -2 cubed will be 8, -8 over 3, then minus -2 squared, that's a 4, then minus 8 multiplied to a -2, that will be positive, and then 8 times 2 will be 16. And then we have plus 3 at the end. And if we simplify this, we get, if we simplify this, okay, -8 third minus 4 plus 16 plus 3. You can simplify by any method you want. If you want, you can use calculator. We will get 37 over 3. So 37 over 3 is the maximum value, okay? And the point on the curve is -2 comma 37 over 3. Similarly, let's find the value of the function at 4, where there is minimum. So if you plug in 4 into this equation, 4 cubed, 4 times 4, 16 times 4, 64. So that will be 64 over 3 minus 4 squared is 16 minus 8 times 4, that's a 32. And then plus 3, which is equal to, if you simplify that, you'll get -71 over 3. So we can say that, hence, the point at maximum, hence the point on the curve, let me write point on the curve at maximum is, so you can see that maximum is at -2, and the point at -2 is -2 comma 37 over 3. -2 comma 37 over 3, and the point on the curve, on the same curve, on the curve at minimum. Okay, at minimum is, we know that minimum occurs at 4, and that point is 4 comma -71 over 3. 4 comma -71 over 3. So that is how we can use the first derivative to test the given function. We are able to find the maximum and minimum value of the function using the first derivative. Okay, that is in part C. And in part B, we learn how to find the interval on which the function is concave up or concave down using the second derivative. And in part A, we learn how to check where the function is increasing or decreasing using the first derivative. So that's all in this video. Thank you so much for watching. I hope this is helpful.